Welcome back, students. Hey, Solar Chefs. This week we're going to be working on our solar oven project. This is the first of a 2-week project where we're going to be figuring out what the problem is, doing some research, creating a solution or designing a solution, creating a solution, testing that solution, all that good stuff, and then hopefully eating whatever it is that you're trying to cook, if all goes to plan. Just don't, when you think about a solar oven, first right off the bat here, don't imagine that you're going to be cooking some frozen steak to a nice well done temperature. That's not quite how these things work. For more information, stick around. I'm going to explain what these things are about and how they work. But first, I want to go over our weekly update this week, just making sure we're all on the same page. If you haven't already, please read this update. This will be really the go-to place to understand what's expected this week. So, the first assignment that you're doing, I'll imagine you read this at home. The grading, yes, basically Monday, today is the last day that you're going to be able to turn in any work by noon, and you got to let me know what you did if you did old work. Otherwise, I'm just not going to have enough time to go back through there and check for every single assignment I've done since the third quarter to know which ones you guys worked on unless you email me. So just to be very clear, by noon today, or Monday I should say, you need to have emailed me whatever it is that you had completed that was late. In other words, that you did not get credit for yet from this week or last week. You need to let me know what you did in email to get credit for it. Otherwise, it's just not going to happen. Okay, that being said, first thing this week is just to watch this video. There's no exit ticket that's along with this video. Just watch it, enjoy. Hopefully, the really exit ticket would be that you're able to get the work done this week, and for your sake, that it's not so frustrating because you at least know what you're expected to do. So the first assignment you actually will end up completing is an eScience lesson on optical technology. It'll be really helpful for you to see basically the different shapes that help you to basically optical meaning like stuff that you can see, but also just manipulating light, making it go where you want it to go or absorb into whatever you want it to absorb into. So that should be a really helpful video, helpful article to help you get ready for designing a solar oven. That's why I have it first. Second is research. You're going to be selecting and reading 2 articles out of a couple that I'll have posted for you. Basically, I'm only saying pick 2 just because this is a shortened week. I'm only trying to give you what you can get done this week reasonably. And so you also have a choice because some people might want to do more of a review. That's one of the article options there. But you might have different questions that you want to try and answer before starting up your project. I leave that up to you. Basically, in the assignment that I'll have posted for optional research, not optional, basically the article option, you will, you'll go into your Google form here and complete it based on the article. So the article will be posted in the assignment, but it's also the HTML link or the HTTPS link is right here. So say you are working on this article here. Read this article carefully, and then once you're done and you've taken notes, go back. Like my phone thought I was talking to it. Typical these days, right? Go back and try and answer some of these questions. I'm not going to keep scrolling down because it'll show you all the answers, but you go down and complete all these questions, and it will basically just tell you, hey, this is you're going to be able to make good decisions based on what you just learned, or you might not have understood it enough to make good decisions yet for your design. Remember, the whole idea with the project is to be able to solve the problem, but you're going to have to understand some science to do that, and you're going to have to be able to apply that. So this is kind of that in-between of you'll do your article research, you'll read the article, take notes on your own, and then you will take this quiz basically to check your understanding, to say, hey, am I ready to go design based on what I just learned? This is not going to be for a grade, but it is for your own understanding. And so we'll go back to this now. All right, so the solar oven project. Our objective for the past couple weeks has been to describe energy as a property of an object associated with light and sound in order to describe how light radiant energy is transmitted by waves. If you don't feel like you have a very good solid basis for what light is or waves are, and you haven't done any work from the past couple weeks, I recommend you go back and at least do the first of all the lessons for the past couple weeks if you haven't already. So this project's objective is to use the engineering design process, which means defining a problem, researching, designing based on your research and designs. Definition of the problem, create the solution to your problem, which will be a model. I know some of us are worried about not having access to the materials. If that's the case, then it's fine. We'll just be creating basically a drawing. It will be the idea. So that design might be the last step for some of us that don't have materials, but hopefully you'll find you have a lot of materials available to you that you wouldn't necessarily think would be materials for a solar oven, because you'll get creative and also understand the science behind it. So this first part, up to designing, is where we're going to stop this week. Next week we'll be creating, observing, analyzing, evaluating. We'll try and post our videos of testing those things and be able to comment on each other's designs and share our successes and failures so we can learn from each other, and maybe even keep working on that over the summer. So before we are able to design something, we need to know what the problem is. So many of our projects this year have been around sustainable development or space industry. So I wanted to just give you a quick breakdown. You might be interested in knowing, in terms of who uses the most energy in the world, you might be surprised to know that which area does. What do you think? So looking at this pie graph here, a pie chart here, you'd say Eurasia, Europe, 22%, 21% is North America, 23% is China, and then 19% is Asia Pacific, excluding China. So Asia in general uses not the majority of the world's energy, but a pretty good amount of it. North America uses almost a quarter. Europe and Eurasia, including basically like Russia, take up another quarter, and then the rest of the world uses a small sliver of the pie, if you would. So keep that in mind. Now, you think which one is the most used in terms of the form of chemical energy, or is it some kind of other energy? So if you're taking a look at this graph here, I wish I could keep moving my cursor, but the thing keeps popping up. You have oil, which takes 33% of the pie, coal, which is another 30%, and natural gas. So all three of those are considered to be chemical potential energy sources, where you're getting your fuel from chemical energy. So you're either burning oil or burning coal or burning natural gas to get energy out of it to do stuff like turn a steam turbine to generate electricity, for instance. So the vast majority of the fuel used in the world in terms of the energy that we've used, it comes from chemical energy. And these are refined chemical energies. Oil, coal, and natural gas. Coal not so much, but natural gas and oil require refinement in their natural forms, from their natural forms to be able to use them. And then a small part of this would be renewables, hydroelectric, and nuclear fuel. Here's a kind of funky looking map too, just to give you an idea. In terms of who's using the most fuel in general, you have, this is what countries normally look like, but then they've been expanded in size, if you didn't figure this out already, by how much they use. This is a weird kind of looking map, but it tells you a lot, right? It's like basically the countries that look swollen are the ones that are using more than others, and the ones that look shrunken are the ones that use less. So you can see basically you have North America, Europe, and Asia, or at least Southeast Asia, taking up a huge portion of the world's energy. And then we think about, well, what about countries that use traditional fuels, like non-refined fuels, things like wood, charcoal, sugarcane, sometimes even animal waste like cow dung. And you can see basically the places in the world that are using less energy end up using traditional fuels more often. So what's the big deal with that, right? Well, if you take another match of this, it doesn't look completely similar, but you can see more distinguishment of those living then, and those countries that use traditional fuels are also living on less than $2 a day. And that doesn't mean that everybody is, but the vast majority of people that do live on less than $2 a day will use traditional fuels. So that shouldn't be a problem in itself. You'd think, well, people have been using traditional fuels for millennia, so where's the problem here? But this was one that kind of comes close to my heart, because working in South Sudan, people often would be using charcoal in their houses or burning basically just charcoal. And using traditional fuels usually leads to lots of health complications and early premature death or stroke. I had quite a few friends that died, or friends of friends that died from smoke inhalation over their adult life that led to cancer. And you say, well, it's not, how is that possible? Well, if you had to burn charcoal in your house every day because you didn't have a fire that you could just turn on in your oven or on top of your stove instantly with clean burning gas, you'd end up having a house full of smoke all the time because you'd have to cook inside. So this is a real problem facing a lot of people around the world, and I want you to take it seriously like that. If you could come up with a good oven that people that live on less than $2 a day could use, that doesn't pollute and also makes use of the resources they have available to them, you could do a great service to the whole world. So I want you to take a stop now and take a look at on the slides of these two videos here. What we're going to be talking about today is appropriate technology. And if you don't know what that means, that's why we're going to take a look at these two videos here, because that's what we're going to try to be designing, is appropriate technology. Okay, so just to define the problem a little bit, think about what the real problem is and try to refine it into something that's measurable, solvable. So if you're thinking about the fuel problems, and if you could think about the this first basically video here, what was the problem that they were trying to solve? Take a moment and try and figure that out. Okay, so we always start with this. What is the engineering problem that needs to be solved? And in this case, it's how to make an oven that transforms light energy into thermal energy. In those places in the world, if you noticed, that live on less than $2 a day, a lot of them are equatorial, which means they're in a place around the world that receives a lot of light energy. Light is free, obviously, and it's also great for turning into thermal energy. So the only question is, the Earth is constantly taking the energy from the sun and turning it into thermal energy. That's why the Earth gets warm, and even now, why it's getting warmer is we have more sunlight. But then we have to think, like, so what's the way to do that, right? So one of the questions you might have had is, like, what's the best material? What's the best shape? So take another moment now to think, how do you refine that into a consolidated problem that we're trying to solve here? And we're not going to worry about budget so much this project, but try and think about all the different questions you might have to answer in order to solve this problem. Okay, so we'll just put it together for our finalized problem here. This is your problem, should you choose to accept it. To make an object that collects electromagnetic energy and turns it into thermal energy and keeps the thermal energy inside. That's basically what an oven is. It's something that keeps energy inside, thermal energy inside, and as you add more into it, it keeps ending up putting that energy into the object you're trying to heat up. So I'd like you to stop and create a list of questions right now. What research topics do you feel will be relevant? What else do you still need to understand to build an effective oven? And after you've done that, we can move on here. So in the research here, you can use 3 sources for your research. Actually, we're going to be using two of the posted articles. And the purpose is to find out information that will solve your questions or answer your questions. So you complete those exit tickets like I said, and then basically we'll be designing a solution after that based on your research. So that solution will include a ray diagram. This is an example of what a ray diagram is, but I've posted a way of actually creating something like this in the in the assignment that I've listed for you there. So this is just basically the same kind of project, just in a different way right now. And let's get to work.